Let's get started. As I was just saying to Jeremy, this is our 41st SBA webinar, which I think is a pretty incredible feat for everyone that's been involved with Sustainable Builders Alliance over the last 5 or 6 years. My name's Hamish. I'm one of the founding directors of Sustainable Builders Alliance, and I am the director of Sanctum Homes, and I'm going to be your host for this webinar. In the spirit of reconciliation, we would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to past, present and emerging, elders past, present and emerging, and we extend our respect to all Aboriginal and Torres Strait Islander people today. Today, I am joining this webinar from Wurundjeri Land, which is the land around Burrawong in Melbourne. Now, our presenter today, I don't actually think needs any introduction. We've all seen, I was about to say enough of him, but we haven't seen enough of Jeremy. But he is prolific, positive footprint. He's on the board for Design Matters. He's
Not
won
anymore.
multiple
I
awards.
used to be.
Used to be.
But I still do stuff with them. Yeah, like the True Zero Carbon Challenge that I hope to talk about a little bit today.
He's won multiple awards, and we feel very privileged to have him as part of the Brains Trust of Sustainable Builders Alliance. I'll let Jeremy explain what he's going to talk about in a second, but today's webinar is brought to you by one of our platinum sponsors, WeatherTech. I know at Sanctum Homes we've been using WeatherTech for a number of years, and it's a really amazing product. It actually has a better than zero carbon footprint, which is pretty topical given the topic today. It's Australian owned and made, 100% natural, 90% natural timber and 3% natural wax. It's termite resistant and all sugars and starches have been removed. And there's no added silica glues, resins or formaldehydes, which makes it a really great, safe product to work with on site. You can check them out, weathertex.com.au, or pop down to your local Bowen's store to grab some samples. Going to do a bit of a boring disclaimer before we jump into this webinar. So all content provided by Sustainable Builders Alliance should be used as general guidance and for reference purposes only. Always seek independent advice and if required verification, no matter the circumstances, including but not limited to instances where loss or damage may occur. No account has been or will be taken into consideration for specific circumstances. No content should be relied on in that way. Views and opinions are solely personal and that of the person of the time of publication and may not reflect the views and opinions of Sustainable Builders Alliance. SBA makes every effort to ensure content is accurate at the time of release. Sustainable Builders Alliance accepts no responsibility for any content that may become inaccurate over time. So we've got about a 45-minute discussion or presentation from Jeremy, and if you do have any questions, please pop them in the chat down the bottom or in the Q&A, and I'll throw them to Jeremy afterwards. But without further ado, Jeremy, I'm going to throw it over to you.
Beautiful. Thanks, thanks, Ham. Thanks everyone who's on this call for coming. Monthly Net Zero Explained. It did have a working title, Not All Net Zeros are Equal, hence the seesaw there. And what I want to talk about today is the net zero target under the trajectory for low energy homes or low energy buildings, and how I think it could be better. In fact, I'm advocating that we go for monthly net zero when we're talking about net zero rather than annual net zero. I've got a couple of examples of monthly net zero homes. It's actually some data from one of the webinars that I did previously where I went into the nuts and bolts, but I'll be showing that and just discussing a few more thoughts on that. And then I want to go over how to actually achieve monthly net zero outcomes. The SBA roadmap, I want to give you an overview of that, what resources there are and what things that you need to know to make monthly net zero more of a standard for the industry. And then we'll see how we go with any questions. I promised 45 minutes, but maybe my time can start now. All right. So I'll start where I often do start, which is with the impact of homes. Some of you have seen some of my presentations, may have seen this balloon before. The average home through its fossil fuel burning to provide the energy for the home, releases an average of 5 tonnes of carbon dioxide a year. Now, when I started giving these sort of presentations 10 or 15 years ago now, that was 6 tonnes. So it's actually a good news story, this 5 tonnes. We've come down because coal plants, some of them have been retired, and we've got more renewables into the system and a lot more rooftop solar. So the big hope and the big aim of Australia's commitment to net zero really depends on getting a green electric grid and getting as much homes and businesses and everything onto it. So I'll be talking about monthly net zero in relation to that goal that that we're traveling as a country. I do want to point out the other big bucket of carbon dioxide release for our homes, not just the 5 tonnes of operational carbon that gets released every year, but there's the embodied carbon. Best information we have on that at the moment is approximately 1 tonne of carbon gets released in creating the materials that our homes are made of per square metre. That's around about 200 tonnes plus for the average new home. A really big problem, something that we need to focus on, but something that I'm not going to focus on for this talk. This talk, we're going to be looking just at operational carbon and operational energy use. But important to remember, don't forget, embodied carbon is a thing that we need to focus on. All right. Apart from carbon, the other impact that our home has, it has a big impact on our electricity grid. How energy efficient the performance of the homes has a big impact, because as you see there, the residential buildings are responsible for 24% of all electricity used in Australia. That means how we build makes an impact on that percentage. And remember that we're currently aiming for about 200,000 new residences every year. It's not quite reaching that at the moment, something like 170,000 or so, I believe, at the moment, but that's what the government's aiming for. But that means within 5 or 6 years, we've added another 1 million homes. So that 24% is only likely to grow. And this at a time when we're trying to do this energy transition. We certainly don't want the next 1 million homes to be as high demand as the last 1 million homes. Remember, we've got to provide infrastructure for this new green grid. And if we don't want to cost an absolute bomb, we have to keep that the demand down of what we're putting onto that infrastructure. And don't forget, we're trying to, not only for new homes, we're trying to electrify all homes. And this is coming in the next 10 years as the government pushes towards a 2035 target of 62% carbon reductions on 2005 levels. On top of all new homes, we're also trying to electrify all businesses. On top of all businesses, we're trying to electrify all industry. On top of that, we're trying to electrify all transport. And we're doing this because if we can put these things onto an evergreening grid, the carbon emissions of Australia go down if we can green that grid. So that's the logic to it. And on top of that, of course, we now have AI. Already about 5% of our electricity use in Australia goes towards AI, and that's set to double by 2030. So there's a lot of pressure on this grid. This is already a grid under pressure, and we're trying to do this energy transition. So what I'm proposing is that our homes need to align with this ambition for Australia, and not only need to align for it, they need to not be a burden on the grid and support the energy transition. Okay, this is also partly what the code is already trying to do, and there's a really useful document. If you haven't read it, it's called the Trajectory for Low Energy Buildings. That's the document that drives the energy efficiency measures in the National Construction Code, and it's the document that is responsible for us having 7 stars and whole of home in the house, in the NCC now. I won't go through it completely, but this trajectory goes until 2030. There's actually a new trajectory for low energy buildings, an updated version, which you should also get and have a read. When you read of that to see where sustainability is going over the next 10 years, you will see the word embodied carbon written a lot in that document. So just a heads up there. But this current trajectory has 2030 as its endpoint, and by 2030, it's aiming that all buildings, residential and commercial, be zero energy and carbon ready. And if I just read out what that means, a zero energy and carbon ready building has an energy efficient thermal shell and appliances, has sufficiently low energy use, and has the relevant setup so they are ready to achieve net zero energy use and carbon if they are combined with renewable or decarbonised energy systems on-site or off-site. So effectively, that's an energy efficient thermal shell, reasonably energy efficient appliances, such that if you put photovoltaics on the roof, you will get an annual net zero outcome. Now, I've been pushing for this for years, and it was actually, I found it amazing when this got into the code. A lot of people were pushing hard for this, but I've now come to think that annual net zero has some issues and maybe isn't what we should be aiming for. Let's have a look at what most net zero homes who achieve that annual net zero, producing as much power over the year as they use, what they're actually achieving. So here we have a graph of annual net zero. This graph, hang on, I'm just going to move something that's on my screen out of the way. This graph is for a 7-star home built to perform to that rating in Canberra with inefficient appliances and a 7 kilowatt PV system. It could also be, you get a similar graph if it was a 7-star home, maybe not built to 7 stars, maybe built to 6 or 5 stars with a mixture of efficient and inefficient appliances. You get a similar sort of outcome. But if I just explain this graph, at the bottom you can see in sort of that aqua blue is hot water. Under NatHERS that stays pretty constant all year, similar requirements all year round for hot water. Above that, we've got household appliances. These are plug-in loads, and NatHERS again just assumes that they stay pretty constant all year. Then in summer in Canberra, there's a little bit of cooling required. That's the blue there. And then you can see that there's quite a lot of heating required, and this is it with inefficient heating as well. This yellow line here is the solar being produced from the 7 kilowatt system on the roof. If I just colour that in, you'll see this is what people generally mean by annual net zero. They mean that the power that's produced by your solar over the year, if you add all that area under the curve there, is pretty similar to that area of demand that the house needs. Once you get those the same, effectively, you get annual net zero. But I think if you look at this, you can straight away see that there's a problem with annual net zero as a goal. And it's pretty obvious that the power when you make it is not when you need it. And that's why I think monthly net zero is a better way to go and a much more useful target for the industry and something we can actually achieve. This graph, by the way, is from Powerhouse Engineering. They produced a new tool that really features and makes it easy to see this monthly net zero. You can see this house, it's producing more power January, February, March, April than it needs. In the middle of the year, it's drawing more power than it produces. And then at the end of the year, again, when the sun comes out, it's producing more power than it needs. So you'd call this 8 months net zero, I guess, under this, this methodology. This Powerhouse app, I'm hoping to show it a little bit more in the future because the real beauty of it is it's designed for designers and builders and energy assessors to a certain degree, but to make it easy to actually interact with your house energy rating, try different variables, try swapping in and out appliances, and trying to make your own home that you're putting through the system, you know, as monthly net zero as possible, hopefully for 12 months. Okay, so that's what most homes now who say they're net zero are achieving. What's the problem with this? So the problem with this, in warmer months, the house produces more power than it's needed, but only during the day when sellback prices are very marginal. Hot water and household loads remain high, and they're often on at night when demand is high and prices are high. So even you're producing a lot of power, but you're not getting much financial return typically for it. And you're still drawing power at night. Winter months. Solar production is less and not meeting demand when you need it. And at night and on cloudy days, there's a large demand for heating and little or no PV production. This will be at peak times when everyone needs the heating and the prices are high. So what does this lead to? Even though you've achieved annual net zero, the house is still expensive to run. You're drawing most of the energy that you need at peak times when those prices are high. And even if this house had a battery, that would be pretty useful for those summer months. But this house is not making enough power in winter when it really needs it to fill that battery. That is, its demand is outstripping the solar resource. And such a house, even though it's net zero, even though it's better than a standard home, it's still a big drain on the grid at peak times and is exacerbating the duck curve. What is the duck curve? Here we have a picture of the duck curve. It's simply the electricity grid demand curve versus price, and called the duck curve simply because one analyst thought that it looked like the back of a duck, hence the name the duck curve, and it just stuck. But let me just explain this duck curve and how it works with current production of renewables. In the morning, people wake up, no sun shining, it's dark, or at least it is for builders when they wake up. Turn on the appliances, maybe have a shower, cook breakfast. You get this high demand spike early in the day. People go off to work, sun comes out, a lot of renewables come into the grid, fossil fuels back off a little bit, and the price goes down because there's often a lot more power needed or in the grid than is needed. It really drives those prices low. And one thing you have to know about the national electricity market is it likes to try and have even prices, unlike this big ups and downs. In fact, if prices can potentially become negative, and that is bad for the stability of the grid, which is why if you're now putting in solar panels in Victoria, at least where I work, they will have a curtailment ability on them so that utility providers can turn off the power going into the grid if it's becoming a little bit unstable. Then later in the evening, sun goes down, the renewables from your rooftops and solar farms and things drop off. And again, people start turning on lights, cooking dinners, having showers, getting ready for bed, doing all that stuff. So you get this extra peak here. Now, the issue with this is that as we add more homes into the grid, it's actually just adding more demand at these high demand times. And what we need to do if we're trying to minimize the infrastructure we know in the grid, our infrastructure needs to be enough to cater for these high demand periods. So effectively, we need to be lowering house demand at peak times if we want to be doing sustainable homes that mesh with Australia's commitment to a renewable future. So to lower demand at peak times, we need to do these things. Minimize heating and cooling loads by focusing on good design and good construction. So we are back to a shell first sort of idea here. Choose efficient appliances, cut that inherent demand of the house so it's not adding too much at those high demand periods. Then we need to make use of this resource of all this sunshine and shift what we can to midday hours. Now, whether you've, so hot water would be one. Hot water uses a lot of energy. Let's try and make that hot water in the middle of the day when we have all these renewables in the grid and the carbon intensity of it is very low. Of course, if you have solar on your roof, you know, you may as well you'll be producing a lot of power in the middle of the day typically, especially in those summer months. Let's put it into hot water. When you get an electric vehicle, or even when you're building new homes, you should be setting up now for EVs. When owners gets them, they can put them onto the middle of the day, again, to soak up that energy resource there. Pool pumps, if you've got a pool, make sure it's got a timer on it to work in the middle of the day. Appliances as well. You can talk to owners potentially about considering when the sun is out, that's the time to do the washing or wash the dishes or so forth. Once you've done that, once you've minimized demand, load shifted things to the middle of the day, then we need to put in, well, then the next step would be to put in batteries. And the idea of putting in batteries is to get this solar resource from the middle and start shifting it to those high demand periods. So of course, a house battery, and most of you will be familiar that there's a federal 30% rebate or 33% rebate, I think, on batteries at the moment. So house battery is good. EVs with vehicle to house technology, they will be coming within the next 5 years. The protocols are already set. Some of them are already starting to hit the market. That's where your car effectively becomes the house battery at night. Car batteries are typically at least 3 times bigger than the normal house batteries you see on the side of the wall, than your Teslas and so forth. And for the government, I'd like to see them making more use of this resource, bringing on local and regional storage batteries that can then supply those high demand periods later on. And in particular, I think this is a no-brainer idea. It's to make EV charging very cheap, if not free, in the middle of the days. Will promote more EVs being sold. People can then charge their cars in the middle of the day, come home, plug them into their houses, run their houses at night. That's where I'd hope things could potentially go. All right, so what should we be aiming for? Instead of this, the annual net zero, we should be reducing demand first, then putting on solar and aiming for this, monthly net zero. So this graph is exactly the same. The solar is still at 7 kilowatts. That line is exactly the same. But now we've used efficient appliances and built the house well and got it under, under every month. This doesn't mean that every day of the year you're going to produce more power, but on average, over the month, most days in every month, you're going to be producing more power. Why is this useful? It's useful because once you get to this monthly net zero, you can do pretty amazing things with batteries. I want to show you now two homes. Both these homes are from the Positive Footprints Carbon Zero series. This is not predicted data. This is actual data from the homes themselves, lived in. This house, $300 in credit, producing more power than it uses during the year. What you're looking at here is each month of the year is along there. Above the line is the energy drawn from the grid. Below the line is the energy exported to the grid from the 11.62 kilowatt solar system. You can see each month it's producing more power than it's using. So technically monthly net zero. This house, 8.3 stars. I didn't have a whole of home score on this one. This was before whole of home became mandated and the softwares were working. However, from work that I've done with True Zero Carbon Challenge and my own jobs, I find that we start to hit this, if you're looking for a whole of home score to sort of aim for, anything from 120 onwards is what you should aim for. Many may not realize that whole of home score goes past 100, but it goes up to 150. So 120 plus is what I'd be aiming for if you're aiming for this net zero, monthly net zero outcome. And why would you be aiming for that? And by the way, this house also has a pool and a young family, and still can achieve this. But why is this good? It's good because when you combine it with battery, you get something like this. Here's another house. This one's $500 in credit, slightly bigger PV system, similar floor plan, similar house size to the other one. This one has an elderly couple. They spend most of their time a day in the house a day. They have their extra drawer is an electric car, so they charge the electric car. So not only are they $500 in credit each year, but they're also another $800 ahead from charging their car at home instead of buying petrol for it. And the house is all electric, so there's another $300 ahead from not having a gas meter connected on the home. But I just want to point out a couple of items about this house. And for those people who've seen the webinar, particularly about this house, I have shown this before, but I think it's important. You can see here above the line, for most months of the year, there's effectively no power draw at all, extremely low demand. You could have another million of these homes on the grid and you wouldn't have to change, hardly any infrastructure because they've got extremely low demand. So I'm calling this a very resilient home. Why is it resilient? It's resilient because this house can go, if there's a blackout, this could go days, weeks, potentially months at a time offline. Potentially the whole year if the owners sort of manage this in middle of the year period a little bit, because it's drawing a little bit more than it's producing there, but not very much. So you get these really resilient outcomes, assuming you choose a photovoltaic system with islanding on it and the battery. These green lines show all the power that's being sent out to the grid, and it translates to enough power for 2 equivalent performance homes. And this power is being sent to the grid not only during the day when it's being made, but it's also being sent to the grid by the batteries at night, and could be set up to send at those peak periods to support the grid at those high demand times, to give more resilience to the whole grid infrastructure. And you can imagine as well that if this house was in the country somewhere, and God forbid there was a fire, forest fire, and hopefully if this house didn't get burnt down, potentially this house could be, supplying power with power cords to neighbouring homes, charging electric vehicles and pumps and different odds and ends. So this was also an energy hub, this house that we're putting on the grid, that has gone on the grid. As I said, these are real figures. This house exported over that 12-month period 9,224 kilowatt hours. That's how it gained its credit instead of paying the average dual fuel bill for a Victorian home, 2,228. Like I said, it's $800 of saving in petrol, another $300 for not having gas. So this is a low cost living lifestyle if you get a monthly net zero outcome plus a battery. And all those kilowatt hours that are sent to the grid offsets the needs for fossil fuels to be burnt to provide that power, and that saves 10 tonnes of carbon going into the atmosphere instead of the average of creating 5 tonnes. So you get a carbon negative footprint. So when people ask me what is a monthly net zero home, I say it's a resilient home, it's an energy hub, low cost living lifestyle, a carbon negative footprint, and something that helps with the green transition, a grid-friendly home, let's call it that. If you want to know more about that particular home, you can go to our webinar resource. Ham said that we're now up to our 41st webinar for SBA, and you can find just about all of them here. And if you click on that one, you can find out what made that house tick. There's also a part 2 that looks at the embodied carbon. This was a true zero home, which also accounts for embodied carbon. All right, how do we achieve monthly net zero outcomes? So what do you need to know to achieve those sorts of outcomes? Well, the good news is all the information resides on the Sustainable Builders Alliance website. You click on the roadmap tab and you'll see that there's 5 different steps on the roadmap to achieving net zero and true zero outcomes. And those 5 steps are: good design is step number 1. Design a home that in the first instance doesn't need much energy to heat and cool, because the climate does it for it with the good design. Step 2, low impact material selection. Build the house with lower carbon, more sustainable materials. Step 3, performance construction. Build it on the ground to perform to its energy rating. Step 4 is efficient appliance selection. Fit it with efficient hot water, heating, lighting, cooking, and appliances, so that has minimal demand. And the last step then is energy generation and offsetting. Provide enough on-site energy generation for net zero and true zero outcomes. So that's the 5 steps to a true zero carbon home. In this talk, like I said, we're just talking about operational energy. So we're just going to talk about net zero sustainable outcomes. And what I want to do now is just give you that overview, that high vision look at how to actually achieve this, and then some pointers and some guides on what you need to know and where those resources are that you can you can get up to speed quickly and start producing homes that do exactly this. By the way, when I'm talking about net zero from here, I'm really talking about monthly net zero. Okay, so here's a house. It's a nice cutaway, so it shows all the technology that we need to talk about. Here's a pie graph of the average electricity use. I'm sure that many of you who have seen me do presentations before have seen me use this pie graph before. I use it quite a lot because it's really useful for showing the benefit of strategies and the effect that they have vis-a-vis the average home that's currently sitting on our electricity grid. The average home, by the way, if you averaged all homes, new and old, across Australia, you'd get a 3-star home approximately. And this is how the energy gets split up. This pie graph also equates to that 5 tonnes of carbon dioxide that gets emitted. All right. So the main strategy to achieving monthly net zero is doing cost-effective things that minimize each one of the wedges on this pie graph here. And the first wedge and the main wedge is space conditioning. And the easiest way to start minimizing your space conditioning, or the place to start, is with step 1, good design. Now, under the National Construction Code, we now have to achieve 7 stars or beyond, or at least those states that have signed up to it so far have to achieve 7 stars and beyond. And there's a good reason for that. That's because a 7-star house compared to a 3-star house, potentially can achieve these sorts of savings on the average home. And of course, if you add 8 stars, 9 stars, or a 10-star home, you can achieve more. It's worth pointing out also that this is an average pie graph for the average Australia, but if you're in a southern location or an alpine conditions or Tasmania, that space conditioning wedge can often go, at least to 60% mark. So it can be significant, which really shows that good design and getting a good design is a really useful place to start if you're going for monthly net zero outcomes. All right, now what do you need to know, or what does the designer who's doing the design for the house need to know? Well, simply they need to understand and be able to use passive solar design. This is an age-old principles that people have been working with for thousands of years to basically allow the climate to do the heavy lifting and keeping the temperatures comfortable with inside a home. How to find out what the passive solar principles are? If you click on good design, you will go to step 1, and step 1 lists out the 5 rules of passive solar design. If you click on each one of those, you can find out about those and read through practical information of what the rules are and how to apply them on builds. Wherever you are in Australia, there's different strategies, obviously, for tropical versus cooler regions. Now, one thing that I want to point out here, if you haven't already looked at it, is the 7-star plus cheat sheet. That's a free resource to download. And some of you may not realize, but I'm also, as well as a builder, I'm a long-time thermal performance assessor. I've rated literally, over 1,000 buildings over my last 20 years. Some of them are mine, most of them aren't. And I've also spoken with a lot of raters over that time and good friends around Australia. So what I've done in this cheat sheet is basically put down all the learnings under the 5 different principles, passive solar design, of things to check on your plans. And this is a really good way to maybe assess whether the plans are on track that you're doing. But also, if you're not all that familiar with passive solar design, is a really good way to get up to speed. Read through it. Anything that you're not sure about, there's actually links in this document back to the website, back to the right part of the website, to have a read, to just gain that understanding. So a useful resource for getting up and running on how to achieve 7 and beyond. Also, under each step of the website, there's webinar links to useful videos. And for this particular step, this one you'll find down there, designing for thermal performance, would be the one to look out for. Little tip here when you watch any of these, if your video player has a ×2 button, I would recommend giving that a go and seeing if you can keep up with it. The only thing that you'll find is that once you get used to listening at ×2, once you go back to ×1, I sound really stupid. But anyway, there we go. There's a little tip to go through it in twice the speed. All right, so assuming the designer knows, has a reasonable grounding in good design, you should easily be able to get 7 stars or beyond. The question is, how much energy does that actually save you? And the answer is we don't actually quite know at this stage, because the part that isn't covered currently in the code is the build quality. You need a certain build quality and performance construction to be able to achieve those savings on site. So this is where a builder comes into the picture. And what would a builder on your team, if you've got a builder, or if you are a builder, what do you need to know? Well, typically you need to understand where buildings fail thermally and how to build for thermal performance. Now, if you're a passive house practitioner, you've probably already got systems and are really sort of keyed into this. But not all homes are passive homes, and actually standard construction is pretty tricky to get right if you don't have your eye on that thermal prize. If you don't understand where you're shooting for, it's easy to make mistakes that impact that rating performance. Step 3 of the SBA website goes through what you need to know, what the assumptions are and what you're actually aiming for. Also talks about, there's a lot of information about condensation and mold in performance construction, which is a hot topic at the moment. So that'll give you a good background on the theory and practice of minimizing condensation and mold. And also a discussion of different strategies for healthy indoor air quality. But this is what I want to point out. It's the builder's thermal performance checklist. This goes through all the areas in standard construction where it commonly fails. Those are the pitfalls. And then has 2 strategies. One, particularly for designers, are things that you can do to design out issues from the start in the design so they don't come up. And then for builders, it's got control measures for each of those pitfalls, and it's got pictures and explains what's going on in the picture. And this is so control measures so the builder can check things on site and control them before moving on to the next stage of the build. To go with this information, there is a SBA tool that can be downloaded, free to download, free to the industry. And this, I think, is a really useful document. For builders, as we're moving into a period of high performance construction, especially if we're promising net zero and true zero sort of outcomes, it's important that we have a strategy so we can ensure the thermal quality of our builds time and time again. And that's where a QA checklist really comes into its own. It also acts as a bit of a risk management tool in that you can show, all the things that you did on the build to achieve the performance outcome. You can give it to your project manager, someone on site, and it's really just simple little things to check at each stage of construction, because with standard construction, if you miss things early on, if you don't get the insulation right before the plaster goes on, well, you've missed your opportunity. If you don't cork before, the plaster before the cabinetry goes on, you can never get to those gaps and cracks. This will help it be, help make it more likely that that the builder and the team on site will be able to control for potential issues. And if you're wanting a builder who knows this stuff, or a designer who knows how to do climatic design, good design, or you're wanting an assessor or a trade who is on board and talking the same language, we have now introduced something called the Sustainable Builders Directory. So you can go and you can look up members who are on that. And if you're a builder, you can find looking for a high performance designer to link up with, because you're interested in building high performance home, you can find them there. If you're a designer looking for builders who can actually build your home to perform, to meet that vision that you had in your head and that the energy rating said, you can find that builder or that trade or that assessor here. You can build up your green team. Of course, if you're a homeowner looking to put together a group of practitioners who are all talking the same talk, all on the same page, and can work together, again, this is a good place to come and list. When you do come to this page, there's a number of filters, but just look for these badges. What these badges are, these are our sort of quality control measure, if you like. To get one of these badges, is one badge for each of the steps under the roadmap to net zero homes. To get it, you have to learn and understand the material that's on the website and do an accreditation that shows that you've interacted with it and understand it. So yeah, look out for those badges. It just sort of sets a bar to keep out people who might want to be on here for greenwash reasons. And you can become a member and list yourself up there as well. Okay, so assuming you've got someone who understands performance construction, a builder on site or a team on site, you should be able to achieve on site, on ground, most of, if it's 7 stars, most of the 7-star performance that the rating says you will. Or if it's 8-star or 9-star or 10-star, you should be able to achieve that. All right, but look what's left. There's still a big lot of the wedge left. And the rest of the wedge and the energy, the amount of energy that the house uses depends on the efficiency of the appliance and efficient appliance selection. And that is why we don't just have a star rating anymore. Under the National Construction Code, we've got NatHERS, what they call whole of home. And that looks at heating and cooling plant, hot water units, lighting, cooking, and it even puts in an appliance plug load into the mix, although you can't technically interact with that. So what I want to do now is just continue around each one of these wedges and very quickly show you the technology you should probably be reaching for. And at the end, I'm going to, again, show you what sort of information you need to know and understand and where the resources are. So if we look at this space conditioning wedge that we still have left after we've done our good design and build it well. Yep, just there. The technology of choice to try and minimize that is AC heating and cooling. AC heating and cooling is a type of heat pump. It's an air-to-air heat pump, and heat pumps are one of the technologies that have sort of revolutionized net zero construction and made it practical and achievable and cost effective as well, for that matter. And a good heat pump, because they're not actually making heat, they're just shifting it from the inside, from the outside unit to the inside, of the inside to the outside in reverse mode. Effectively, they can make, if they use 1 kilowatt hour of energy to run, they can typically at least shift 3 kilowatts, 4 kilowatts or more of heat. So unlike conventional plant, if they want to make this much heating and cooling, they can make it with approximately 1/3 of the energy or 2/3 less energy. So let's just stick that in there. There are some criteria of how to size and how to find them, which I'll talk about shortly. The next wedge, water heating. So there's 2 technologies to look out for here. Once again, heat pump. This time it's a hot water heat pump. This is an air to water heat pump, what they call an air to water heat pump. And the other technology is a humble shower, a 4-star Wells shower. The reason I put this in is a shower, 50% of your hot water goes through a shower. So if you have a more efficient shower, as long as it's a good shower, I'd always recommend you choose and don't skimp and put your money into a good 4-star shower. But if you're, for any given shower, if you've got a more efficient shower head, you're using less water, hot water, and therefore using less energy. So if you put a 4-star shower on your builds or in your different bathrooms, effectively you can make a little bit of a saving there in that hot water wedge. And notice here that it's green. So it's green for a reason, and that is because this represents an energy saving that is not accounted for under NatHERS. NatHERS doesn't allow you to enter the efficiency of shower heads. And this means that effectively, if you put in 4-star shower heads, your house on the ground should use a little bit less energy than the NatHERS report says. So this is something I call, I think of as headroom for a builder. As builders, especially once you're offering a high performance product, it's nice to have these little headrooms in there, such that if the weather's not so good or more people come around to the home, or there's a bit of overshadowing or something happens, you've got that little extra up your sleeve before clients come and complain. So there's a nice little tip. The other technology, of course, is heat pump hot waters. Once again, they can make this much hot water with, almost 2/3 less energy. So this gives you an indicative idea of the energy savings there. The other thing to consider with hot water systems, please make sure that you choose ones with a digital timer on it so that it can be set to heating in the middle of the day. So if you've got solar on your roof producing a lot of power, you can be heating your hot water. If you don't yet have solar on the roof of the job, it can be drawing from the grid at a time when a lot of other people are pumping solar into the grid, and the carbon intensity of the electricity is a lot lower. Either way, it's good to load shift to the middle of the day. All right, this lighting wedge. This is a pretty easy one. Simply use LED lighting there. Quick rule of thumb, choose pendants where you can. Pendants tend to, you need a lot less pendants. Every pendant typically replaces 4 downlights in the amount of light that it spreads. And when considering globes, this is just a rule of thumb you might want to consider. 1 to 2 watts, allow 1 to 2 watts per square meter for living spaces. It's typically the rule for lighting. And for study areas and areas where you want more light, 2 to 3 watts. If you sort of keep to those sort of general rules of thumb, you should find yourself getting a bit of a saving on that lighting wedge compared to the other home and the existing homes. And also on the NatHERS tools, you should get a little bit of a saving there. Under cooking, there's only really one technology to consider, and that is induction cooking. Induction cooking typically is 55%, they say, more efficient than gas cooking because a lot of the gas tends to go around the side of the pots and pans, whereas induction cooking, it goes straight in. One of the things though, so you do get a little bit of an energy saving there in the cooking wedge, but one of the things I really like about induction cooking is from a health management point of view and a mold point of view. When you're burning gas, gas combines with air, the methane gas combines with air, and the outcome is water vapor. So if you do go induction cooking, you're typically saving 2 litres a day of water vapor going into the internal environment. And as any of us who have looked at condensation and issues of mold growth within homes, especially high performance homes, the first control strategy is trying to limit the amount of water vapor that you're creating inside the home. Induction cooking does that. They're also, of course, easy to clean. The other thing that's great about induction cooking, this is usually the last holdout appliance, the gas appliance in the home. And if you go induction, you can get rid of the gas meter, and then you save that connection fee, $1 a day or so, $300-ish a year for the clients for the life of the home. The other nice thing, once you go all electric, as that grid greens, that we're trying to green that grid, the house will green as well, and the operational carbon emissions will eventually disappear if we can completely green the grid. All right, the last wedge is appliances, and this is actually a big wedge, and we can make quite a big impact on it, even though under NatHERS just assumes that it puts an appliance like into the calculation, but you can't. These are plug-in appliances. You can't adjust it. It's just a load in there. But in reality, you can have a bit of an effect. Usually, if it's not the builder or the designer specifying things, it'll be the clients. And often on a new home, clients are putting in a lot of new kit, often into a new home. So it's a great trigger point to make a bit of an impact by having a quick conversation and trying to convince the owners that you're building this energy efficient home. You're trying to achieve these really low energy outcomes, and energy efficient appliances are a big part of that. So to consider stars when they go shopping, and choose the high star appliances for white goods and TVs. If you do that, you can get up to about 25% saving on that wedge there, which is pretty significant. And once again, it's in green because this is beyond NatHERS. This will make your house more efficient than that, and gives you that safety, that headroom for what you're promising here. All right, what do you need to know for appliances? You need to know these 3 things. You need to know how to choose efficient units, how to size up required capacities, especially with heating and cooling, and then how to put the correct information on the plans for the NatHERS rating. What information do they need? What is an efficient rating versus a non-efficient rating? What should you be looking for? I'm not going to go over it today. What I'm giving you today is an overview so that you sort of know where you're going. This is the roadmap of where to go. But if you do go to step 4, you'll find energy efficient heating and cooling, hot water, lighting, induction cooking, and high star appliances that give you all that information. Importantly, under each one of those headings, you'll also find a template. And the template is the information that you need to put on the plans for an easy energy rating, for a quick energy rating process, rather than the assessor coming back to you asking you what you're using for, you know, your heater and your cooler and your hot water, and having to spend time doing it. You can present all that information up front. Importantly too, these templates also have steps on how to choose more efficient versions, what you need to know if you need to size things up, and yeah, any other information you need to fill in the tables. And then you can put them on your plans. Your assessor will love you. Another tool on this page is the SBA Builders Appliance Recommendation template. And this is just some useful information that you can give to clients if they're the ones selecting the appliances. And it just simply tells them the importance of the white goods that they'll be selecting. And importantly, it has this. It has worst and best performance of each of the major items that they'll probably be wanting to buy. It's important that you know when you go shopping, you know what, all these stars are different. They don't all go up to 5 stars. They go up to different amounts of stars depending on the item. And if you go off shopping and you buy a 5-star dryer, you might think you're doing well, but you're not doing well because they actually go up to 10 stars. So, and it also gives the savings over a 10-year period, or indicative savings. So this is just something that helps guide owners to think, oh, maybe I'll choose, you know, a more efficient version if it's in my price range. And that can help give that extra little bit of headroom, as I spoke before. All right, so look what we've done here. We've gone around that pie, we've minimized the demand, and importantly, what we haven't compromised on is function. We still have all the exact same function. What we don't have is the cost. It's a lot cheaper to run this house now, and this house is not emitting as much carbon dioxide because it doesn't use as much energy or draw it from the grid. So the next step is energy generation and offsetting, now that you've minimized the fundamental demand of the home. And here we're talking about solar PV system. Now, how much do you need to put on if you want to have this monthly net zero outcome? Well, I'll give you a rule of thumb in a second, but of course you should be asking your thermal performance assessor, tell them I want a monthly net zero outcome. How much solar should I be putting on? If their tool can't do it, they can always talk to the Powerhouse app people and start potentially using that tool too. Though I know at least one of the NatHERS tools also have that functionality where you can get it out. But here's some rules of thumb. For my own homes in Victoria, this is what I'm finding. Once you take this approach and minimize demand, most homes, most standard size sort of 200 to 300 square meter homes, I guess, somewhere around 6 kilowatts, and you start to break even on that monthly net zero, start approaching that monthly net zero. Now, on top of that, I always set up for, and I'd recommend that you set up for car charging in the home, run a 32 amp cable to wherever the car charge is going to be, run that back to the switchboard, have a few empty slots in the switchboard, ready for connecting up when the owners get an EV. And most garages in the homes that we're building these days, within 10 years, they will probably have an EV sitting there. So they will thank you for that. To power an EV and run it for 50 kilometers or so every day, if you set aside 2 kilowatts of power, that will be enough to run most EVs around about 50 kilometers, which is the average city driving. If your owners do have an EV, also remind them to try and charge as much as possible during the day. That's the load shifting aspect. Lastly, personally, I also like to calculate embodied carbon, try and minimize that, and put on an extra couple of kilowatts to pay back the embodied carbon debt of the home over time. If you do it all right, you can find you'll find that you can pay that back within the lifetime of a single system. The other thing I like about putting on an extra 2 kilowatts, again, it's that headroom that I'm talking about. So if you've had a particularly cold, dark winter month, well, you've got a little bit of extra headroom up your sleeve, so the house still keeps performing. So that gives us a 10 kilowatt plus sort of PV size. Now that sounds like a big system size, and it was a big system size until recently. Now the average size is 9 kilowatts. So this is sort of what's going on most roofs anyway. If you do this, you'll achieve this monthly net zero outcome. But I haven't, I've just, I've got these wedges see-through now because you'll be producing more power than you need over a 24-hour period. But because you don't yet have batteries in the system, at night time, you're still going to be drawing from the grid. And so the next step, of course, is to add batteries once you've got this monthly net zero outcome. And that can be a battery bank. I suggest at least 10 kilowatts, which will be enough to take most homes, especially these energy efficient homes, easily through a night or two. And also consider in the future, if not now, some cars are already out there which you can plug your house into. So look out for V2H coming in the next 5 years down the line. Once you put on that battery, then you have these amazing outcomes of basically drawing nothing to the grid or very little, but it's still there. The grid's still there as backup on bad days or when you have parties and lots of people around. So it's good to still be connected. It's also good to be connected because you're sending a lot of more power to the grid, and you're potentially you can feed the grid through your batteries back into the grid at those high demand periods and actually help the grid be more resilient. So more of these homes on the grid actually enables a cheaper energy transition. Lastly, what do you need to know about all this electronic stuff? Well, if you go to step 5, there's actually a section saying PV, what you need to know. And all the information, or most of the information, is there. Also, if you're planning for batteries, again, what you need to know and where that batteries can and can't be located when you're doing the design. Important, especially for designers, to know that one. The only tip that I'll give you is I'm finding now that we do most of our homes with 3-phase inverters. Our homes are now islanded, so they're connected to the other circuits. The inverter's connected to the other circuits in the house. We put in car charging. There's also now the curtailment functionality, and all of these things require switch capacities and switches in your switchboard. So this one on the left here, if this is in your meter box, that is the very minimum. 32 switch system would be the very minimum that I put on. Typically now we put a whole one on just for batteries and solar and car charging. All the stuff goes into there. So that's just a little bit of a tip, makes things easy. There's also a template to do with photovoltaics under step 5 there. And so there you have it. This is the net zero home. This is sort of an overview. And as a very last overview, just to really pound this home, what we're doing here, in the first instance, we're trying to minimize demand through good design, high performance construction, and efficient appliance selection. Then, once we've minimized demand, putting on PV and load shifting. And then that'll give you that monthly net zero outcome, as you can see there. Then adding batteries, which effectively makes the home net zero. And the outcome is a carbon negative footprint, a low cost living lifestyle, a resilient energy hub, and a grid friendly home. So that's it for the major part of the talk. And I hope that was 45 minutes, Ham, but I'm just going to steal one more minute if I can to do a little advertisement. If you're interested about this, what about true zero? What about embodied carbon? What about minimizing that and offsetting that as well? Well, if that's interesting to you, and like I said, the trajectory update talks a lot about embodied carbon. There's a competition on at the moment called the True Zero Carbon Challenge. It's now in its third iteration. This is a competition that I started about 5 years ago at Design Matters National when I was on the board there. And this is a this is a competition for a designer and assessor team to really push the boundaries and see how energy efficient they can make their homes in the first instance, and then to choose lower embodied carbon materials, calculate the amount of embodied carbon in the structure, and create a home that not only produces more power than it uses, as we saw in this webinar, but also offsets the embodied carbon and offsets it by 2050. That's the challenge. I particularly wanted to present this though to any builders on the call, any designers and assessors on the call, please do it. But for builders, over the last 2 iterations, over 30 teams have been able to meet this challenge and produce some fantastic homes. But I want to see these homes being built. And that takes builders, and it takes these homes being on builders, advertising material, so the general public can start choosing them. So if you are a builder, the Sustainable Builders Alliance, if you're a member, you can get 50% off for a team that you submit. So if that sounds interesting to you, I would suggest talking to your designer, talking to your assessor, and looking at the idea of using the competition to create a prototype and to trial it out and do all the testing during this competition so that you can then put something on your books and actually advertise. And let's get some of these homes built. As I said, I'm not sure I said, but there's a 50% discount for members that we've been able to negotiate as a partner in this competition with Design Matters National. So if you are interested, hit me up at education@thesba.com.au. There are already builders doing this. I won't mention any names, but I think you'll be surprised when you hear some of the building companies who are already in this competition. And if you want to be a leader, if you don't want to be left behind, this is only a biannual competition. It's going to be 2 years until it comes around again. That's my last hard sell. But if that's interesting to you, hit me up. Like I said, there's a lot of education, a lot of support in this competition. All right, Ham, thanks for being able to steal that little bit of time at the end there, and it's back to you.
Thanks, mate. Only 15 minutes over time, Jeremy. So you did okay.
A new record.
Yes, I reckon that is a new record. There's only a couple of questions in here, Jeremy, we might just cover before we go. I probably should go and help my wife with our 3 kids. So there was just a question here from Jess asking, what star rating did the house become to be monthly net zero?
8.3 and 8.6 on the ones that I showed you. I showed you 2 homes there. Yeah, 8.3
Could you
stars.
still
But
could you still have a home that's net zero even if it doesn't get up to that highest star rating?
yeah, definitely. So if you go to 7 stars and you build it to 7 stars, that's important. But then you fit it with efficient appliances. Well, maybe instead of 6, or maybe you'll be on 7 kilowatt system. You just need to up your system size a little bit for the home. But the difference is if you don't try and minimize your inherent demand for the home, and you just say, oh, let's build an inefficient home and put a huge system on it, it's just going to cost an arm and a leg, and you almost certainly won't have roof space for it. So this is just a more cost-effective way of achieving the outcome.
Yep. And what do you think of installing a water temp control to avoid overheating water, only to cool it down again?
I would suspect that most heat pump systems don't overheat the water. I think maybe solar hot water systems used to have that issue, and they have that little valve on the side to release pressure. But I think for heat pumps, they do have a temperature sensor in them, most of them, and so only heat when they need to heat.
Yeah, I would have thought the same thing too. And Kim's just got a question here. It's probably a pretty important question because I feel like we talk about building new homes, and a lot of the homes you've got on here are being new homes, but there's obviously this existing building stock out there which we absolutely need to upgrade. And do you think you could get an existing house to reach monthly net zero?
Well, 100% you could. It depends how much you do to it, to get it there. So we do renovations as well. I get a lot of renovate. If I'm doing a major renovation, especially one where you're like knocking down the back of sort of a lean-to house and putting on a new living space, potentially where I tend to work, a lot of the homes are old, and so it's time to sort of replace the old weatherboard claddings. If you get a house like that, then it's not all that hard if you know what you're doing to achieve 7 stars or more, and then yes, you could get a if you're replacing appliances too, why not? You could get it. But I suspect for the existing housing stock, NatHers is working on something called NatHers in-home, which they're already trialing, and they expect to be rolling out next year. And NatHers in-home will have an assessor who goes into the house, does a takeoff of the areas of the home and what the home's made of, do a report on it, and then that report will be linked to potential rebates on getting works done. I think that's how the system is that they're planning the system to work. So yeah, it's definitely going to start happening. Even if you can't get it quite to monthly net zero, as long as you get it along the way there, I think positive outcomes, don't have to be the perfect all the time. They can be an iterative process that existing homes are replacing. When your water heater dies, you replace it with an efficient one. You sort of work your way up depending on what's going on at that house. But yes, definitely
Yeah, I
over
mean,
time,
and
it's really important.
yeah, I was just going to say, like, I mean, don't let perfection stop progress. I mean, every little bit's going to count. Even, putting little snakes at the bottom of your doors is going to help. Like, let's not get caught up
Mm.
on, not doing anything because you can't get perfection. I think we've got to start somewhere.
Uh,
Jeremy, I might wrap it up.
mm.
Thanks again for, coming on and doing these webinars. As I said before, you do a lot of them. You give up a lot of your time, and I know you've given up a lot of your time and a lot of your IP for the SBA website and all the educational pieces that we've got. So, I just want to say thank you for that, mate. We really appreciate it. I'm sure all the attendees here today probably appreciate that too. Um, Now, if you haven't already been onto our website, I don't know if you noticed, Jeremy actually had a great advertisement of our website throughout that presentation. And if you haven't checked it out, it's www.thesba.com.au. A whole bunch of those things that Jeremy showed you are free downloads on the website. So it's an absolute wealth of information on there. So if you haven't checked it out, please do so. On the website is all our webinars. There's 40 plus of them now. And if you don't check out our podcast, you should definitely have a listen to it. The last 3 or 4 on there have been probably some of the best ones there. We've had David Hurley, a young builder from Victoria who works for Carlin Construction. Jeremy McLeod from Breathe and Nightingale was on there as well. And of course, Jesse Clark from Pro Climber. Now, what is ahead for SBA? Later this month, I'm hosting a panel at the Build Expo, and on that panel is going to be Matthew Carlin, who probably needs no introduction, Dylan from Orwin, who's a deep retrofit expert, and Jess from Climature. I think Jess is on this call as well. Don't miss that. That expo is going to be awesome. And also keep your eye out for an inaugural event we're going to be doing with Bowens in November. It's going to be an absolute cracker. I can't tell you too much about it, but keep your eyes peeled over the next couple of days because there's going to be some early bird tickets for that one. Jeremy alluded to the fact that we're now a membership-based organisation. I did post in our chat there how you can sign up and become a member. Jeremy also showed you a little bit of a snapshot of some of the people that are already members on there and they've got their badges. We're on that builders directory. We know that people, designers and clients are actually looking through that now. So, you know, if only you're joining for that, which is just a small piece of the benefits you get as a member, I think that's a really valuable piece of marketing, and it's a really, really cheap piece of marketing. But there's a huge amount of other stuff on there. There's real world learnings. There's a whole bunch of member savings behind the member paywall there. But yeah, definitely check it out. Again, thank you everyone for joining us today. Jeremy, again, thank you so much. And I do apologise that we did change the date twice. And it probably worked out a little bit better for me because I was actually away last week. But anyway, thank you to everybody who came along today, and we look forward to seeing you on the next one. Cheers.